Hey guys, what's up everyone? How are you people doing? Welcome back to today's session, guys. So people, this is the second session of our grade 9th CBSE where we had started off with the chapter motion, and in the last session we did a couple of topics regarding velocity and speed and how do we calculate average velocity and average speed as well. So today we'll be talking about acceleration, and we'll also solve some numericals regarding acceleration. But before all of that, let me introduce myself. My name is Anoop Manoharan. A very warm welcome to all of you guys out there. To tell you a little bit about myself, I'm a master teacher of science here at Vedantu. I've been teaching for the past couple of years now. So yeah, that's pretty much about it. All right. Anyways, guys, like I told you people, today's topic is regarding this acceleration and numericals. We'll try to make this topic as simple as possible for you guys, so that you guys are able to ace your exams and give you a 100% in your exams as well. So with that said, let us get started. But as always, guys, we start off every session with a quote, and this is the quote for today: mistakes are proofs that you're trying. So yes, people, as always, I stand by that. No matter how talented you think you are, make sure that you give your best effort. Try it. Even if you fail, it does not matter, because Thomas Alva Edison, to make the light bulb, he failed 10,000 different times to actually try out different materials to actually get that one thing right. So yes, it's okay to fail, but at the end of the day, don't ever stop trying. All right. Anyways, with that said, people, this is what we're going to talk about in this particular series of motion. So today, like I told you, we'll be talking about acceleration and numericals, and in the sessions ahead, we'll be looking at distance and velocity time graph and the graphical derivation of these equations of motions as well. All right, people. So without any further ado, let us get started. So if you guys remember, if you're in the previous session, we had asked you a small little homework towards the end of the session, and many of you guys did do it. I'm happy for that. Hats off, people, all those who put it out in the comment section below. I'll be putting up the names also of the first couple of students who actually gave the answer like super fast. But this was the question. The question was: John drove for 3 hours at the rate of 50 km per hour and for 2 hours at 60 km per hour. You were supposed to find out what was the average speed. So just to recap the formula, I told you that average speed is basically equal to total distance by total time taken. So total distance divided by total time taken. This was the formula, if you guys remember. Time. So in this case, to find out the total distance, so calculate them separately. So the first case scenario where he drove for 3 hours, so speed is equal to distance by time. So distance is equal to speed into time. So the first one, speed is 50 km per hour, time is 3 hours, so that's 150 km. For the second one, however, it was he drove for 2 hours at 60 km per hour. So it's 2 into 60, that gives you 120 km. So total distance is basically 120 plus 150, so that's 270 km if I'm not wrong. So just put it on the equation, total distance by total time taken. So if you calculate it, that is, I'll just write it down. I'll just erase the first part off and write it for you guys, so that you guys are able to answer the question, just so that, because there's no space for me to write. All right, so let me just put that down. Here we go. So total distance is 270 divided by the total time taken is 2 plus 3, that's 5 hours. So that'll give you the answer to be about 54 km per hour. So that's 5 5s are 25, so that's and 5 4s are 20, so that'll give you 54 km per hour. That's it. So congratulations to Nadira, Fatima, and also Vishwa Ganesh. Congratulations, you guys answered the question like super fast. Hats off. Now again, people, if you want your name to be there in the next session, so comment it down below, whatever the answer is. So at the end of every session, obviously I'll give you a homework. So today also we have a homework. Make sure that you write down the answer and put it down in the comment section as soon as you can. All right, with that said, people, let us get started with acceleration. Now let's start with acceleration by understanding one of the most common things that you see around these days: a bike, right? Now in a bike, generally the left hand side, not left hand side, the right hand side, you have a knob. You have a knob which basically can be rotated, and that is called as the accelerator. If you've ever rode a bike before, or if you have in a car also, you have it in the like the pedals, the accelerator pedals are there. Now the function of these things is to basically increase the velocity. So the more you rotate, the faster the bike goes. The more harder you press, the faster the car goes. So it's basically an accelerator which increases the velocity. Now, let's take a scenario case. Let's say there's a bike which has a velocity of 12 meter per second. So it has a velocity of 12 meter per second. And let's say that every 1 second, his velocity is increasing by 2 meter per second. What do I mean by this? So let's say that at time is equal to 0, he's in the state of rest. So the bike is not started right now, he's standing still. After 1 second, I see that his velocity is 12 meter per second. Alright, so his initial velocity right now has changed to 12, like his velocity, or his accelerator, or basically he turned his knob, yeah, and he has reached a velocity of 12 meter per second. Now, after another second, that is at time is equal to 2 seconds, I see that his velocity is 14 meter per second. And at time it is equal to 3 seconds, his velocity is 16 meter per second. And 4 is 18, so on and so forth. Now, in this situation, if I want to find out what is the difference in velocity, or what is the change in velocity between point B and C. So I want to find out what is the change in velocity between these 2 points, all right, between these 2 points or these 2 time periods. I want to find out what is this velocity, or what is this change in velocity. Now, what I'm going to do is that to calculate this, what would you do? Change in velocity would be what? The velocity of the body at C minus the velocity of the body at B. In this case, the velocity of the body at C was, if you look at the situation, it is 14 meter per second, and the velocity of the body at B was 12 meter per second. So in simple words, it's nothing but 14 minus 12. That gives me 2 meter per second. Very simple. Something very simple arithmetics. So you get it as 2 meter per second. Now here's the thing, people. This change in velocity, how did you actually calculate it? You calculated it by using this formula, that is initial velocity minus the final velocity, or in other words, you can take it as final velocity minus the initial velocity. You don't take it as initial velocity minus final velocity, take it as final velocity minus initial velocity. So there is a quantity that basically tells us the relationship between the change in velocity and time. So there's this quantity which relates the change in velocity and time. That quantity, my friends, is what is called as acceleration. So what is acceleration? This change in velocity per unit time is what is called as acceleration. So in this case, in the previous scenario that you saw, the acceleration is basically 2 meter per second square, because the body is constantly changing his or basically the velocity is constantly changing. So you can say that at every 1 second time, his velocity is changing at 2 meter per second. That is his velocity. If you talk about acceleration, that will be 2 meter per second square. I'll tell you how I came to that conclusion. But before that, let me define what acceleration is. Acceleration is nothing but the rate of change of velocity, or in other words, it is the change in velocity per unit time. The rate of change of velocity, that also means that is, you're relating it to time again, or you can write it as acceleration, nothing but change in velocity per unit time. Both of these are absolutely correct. The formula to calculate acceleration is basically, acceleration is denoted as A, and the formula for acceleration is final velocity minus initial velocity divided by time, where V is the final velocity and final velocity, and U is the initial velocity. U is the initial velocity, and T is the time taken. Simple as that. And the SI unit of acceleration is meter per second square. How did I get it as meter per second square? The SI unit of that is initial and final velocity is meter per second, and time is second. So you'll get it as meter per second square. So that will be the SI unit of acceleration. Now, if you Think about it, guys. There are a lot of, because acceleration is also a vector quantity. That means that it depends on the direction as well. It is not a scalar quantity. It has both magnitude as well as direction, which means that you can have positive acceleration, negative acceleration, as well as zero acceleration. So we're going to talk about what are the conditions in which you're going to get positive acceleration, in what conditions will you get negative acceleration, and in what condition would you get zero acceleration. Let's start with the positive one. All right, let's start with the good news. Now, positive acceleration is one in which the final velocity is greater than initial velocity. In other words, if v is greater than u, then you can say that the acceleration is going to be positive, which means that the body's acceleration or its velocity is increasing. All right, the body's velocity is increasing. That is what it means. On the other hand, if the final velocity is less than the initial velocity, then you say it as negative acceleration, or you also call it as deceleration or retardation. All of these mean the exact same thing. Negative acceleration, retardation, or deceleration, all of these mean the exact same thing, in which the initial velocity is basically greater than the final velocity. In that case, you can say that the acceleration is going to be negative. Now, don't worry about it. We'll also solve some problems based on this. So be ready for that as well. Now, the question is, when do we get zero acceleration, sir? Zero acceleration is something that you obtain when the velocity is constant. When the body is moving with uniform motion, where the speed is constant, where there's no change in velocity. Because when you say acceleration, it's a rate of change of velocity. If the change in velocity is not happening, how can you say that the body is accelerating? So when the rate of change of velocity is zero, then you can say that the acceleration is also zero. So when the velocity is zero, or the change in velocity is zero, or the speed is constant, then you can say that acceleration is zero. That's it. As simple as that, guys. So in this case, the final and the initial velocity would be equal. All right. Okay, people. Now that you've understood all of these concepts, I'm hoping that you did. Let us now get into some of the questions. So I hope you guys are excited for that, because there are a lot of interesting questions, and I hope you guys will be able to do it as well. So with that said, people, here's the first question. Now, everyone take a quick piece of paper and pen, pause the video, go get it, and try to do it by yourself. So here's the question. A car accelerates uniformly from 45 meter per second to 63 meter per second in 9 seconds. Calculate the acceleration in meter per second square. Is it 1 meter per second square, 2 meter per second square, 4 meter per second square, or 9 meter per second square? Pretty simple. Let me just write down the given data over here first. Initial velocity is given as 45 meter per second. Final velocity is given as 63 meter per second. Time taken is 9 seconds. So you're supposed to find out the acceleration. Acceleration is what? V minus u by t. That is final minus initial acceleration divided by time taken. So that's 63 minus 45 divided by 9. So 63 minus 45, I think, is 18 divided by 9. So that gives you 2 meter per second square. As simple as that, guys. So that is the first answer. I hope you guys got the answer for this one. Again, do let me know if you have any doubts in the comment section below. Second question, people. Here we go. A train starts from rest and accelerates uniformly at the rate of 5 meter per second square for 5 seconds. Calculate the velocity of the train in 5 seconds. Is it option A, 5 meter per second, B, 25 meter per second, C, 30 meter per second, or D, is it 0? Now, this is a very interesting question. Try to do it by yourself, but I'll tell you, I'll give you some of the basic information, but I want all of you guys to try it out and let me know in the comment section below what is the answer. All right. So here's the question, guys. The acceleration is given as 5 meter per second square. Awesome. They've given you the time taken also as 5 seconds. Now, here's the thing. They've also given you the initial velocity. And if you have noticed it, it says that the train starts on rest. So the initial velocity is 0. It starts at 0 meter per second. So you're supposed to find out what is the final velocity. First of all, the equation is A is equal to V minus U by T. Rearrange the equation to get V. So V is equal to AT plus U, or U plus AT in other words. That will be much more easier for you to remember. The equation of motion, yeah. So that's V is equal to U plus AT. All right. So substitute the values over here. I don't know the value of V, so I'll keep it as V itself. Initial velocity is 0. Acceleration is 5. Time taken is 5. So that gives me 25 meter per second. Straightforward, very simple, bacha question. The right answer, guys, is option number B, that is 25 meters per second. Very simple. Moving on to the next question, guys. I hope you guys got this as well. Next question again. I want all of you to pause the video and try out the question and then let me know in the comment section. Alright. Here's the next one. Peter drives 150 meters in 18 seconds. Assuming he does not speed up or slow down, what is his speed and acceleration? So speed is an option A, 8.33 meter per second and acceleration 0. Speed is 8.33 meter per second and acceleration 0.2 meter per second square. Speed is 6.33 meter per second and acceleration 0.2 meter per second square, or speed is 6.33 meter per second and acceleration is 0. So let's see, guys, how do we calculate this one? Now, first thing first, the distance is given as what? 150 meter. Time taken is what? 18 seconds. So first of all, find speed. Speed is equal to distance by time. So it's 150 divided by 18. So I can use, I think, 2 to 9s are 18, 2 7s are 14. So it'll be 2 5s are 10, right? I could use probably, I could divide, I could use 3 table, I think 3 3s are 9, 3 2s are 6, 3 5s are 15. Again, 3 divided by 25, I think I'll get it as 3 8s are 24. So you'll get it as 8.33 meter per second. Very interesting calculation. So the 8.3 intense. So 8.33 meter per second is the speed. Now here's the thing, guys. What is acceleration? The rate of change of velocity. But here it says that he's neither speeding up nor slowing down. That means he's going at a constant speed. He's going at a constant motion. If the body is going at constant motion, then the acceleration would directly be 0. Why so? Because we just calculated he's going throughout at 8.33 meter per second itself. That is the speed. So again, if you use the formula A is equal to V minus U by T, 8.33, his initial velocity is also 8.33, his final velocity is also 8.33, divided by the time taken, that is 18 seconds. It will be 0 divided by 18, which will give you 0 again. Anything divided by 0, anything 0 divided by anything is 0. So basically you'll get the answer as 0. Mathematically also you can prove that it is 0 because his speed is not changing at all. He's going at constant speed. So basically his acceleration would be 0 in this situation. Alright guys, well done. All those who gave the right answer. Hats off, people. The right answer to this question would be then option number A, that is his speed is 8.33 meter per second and his acceleration is 0 meter per second square. Alright, next question, guys. Here we go. A person starts his motion in a straight line at a velocity of 15 meter per second. His velocity is changing at a constant rate. If he stops after 75 seconds, what is his acceleration? Is it minus 0.5 meter per second, minus 0.2 meter per second square, minus 0.25 meter per second square, or minus 0.75 meter per second square? Now in this situation, like I told you that you can have acceleration to be positive, negative, or 0. We talked about 0 already. We saw positive acceleration too, but this is an example of negative acceleration. Why so? If you look at it, if you look at the example itself, his initial velocity is 15 meter per second. Alright, his initial velocity is 15 meter per second. And then he stops, which means that his final velocity is 0 meter per second. And his time taken is 75 seconds. Now I told you that if the initial velocity is greater than the final velocity, then the acceleration is going to be negative, or it is a negative acceleration, retardation, or deceleration. So if you calculate it, you'll get the answer for this question, guys. So A is equal to V minus U by T. I would suggest you guys to write down the formula every single time. It's a good practice because even if you end up doing the calculation wrong, you'll still get marks for steps. So it's a good advice to take it up and try to use it in your exams as well. I know it takes a little longer, but it still will definitely help you out. Even if you do some calculation mistake, this would definitely fetch you some marks. All right. So final velocity is 0. Initial velocity is 15. Time taken is 75. So if you divide it, you'll get it as 5 3s are 15, 5 1, 5 3s are 15 again. So you'll get as 3 by 13, which if you further calculate, again 3 4s are 12, so it'll be 1 by 4. Did I make any? Okay, no, I think I made some calculation mistake. 5, okay, it's 25, so it'll be 15, not 13. It's actually 15 because it's 25. Sorry, people, happens. This is why I tell you to write formulas. Because even if you end up making a calculation mistake, it's alright. So 3 5s are 15, so that'll be 1 by 5. So 1 by 5 would be the answer for this question. The acceleration is negative or minus 1 by 5, because over here also you see this, it's minus 1 by 5. If you calculate it, you'll get as minus 0.2 meter per second square. If you convert it to decimal values, you get as minus 0.2 meter per second square. As simple as I guess, that is the answer for this question. For the fourth question, where you're getting the acceleration to be negative, which shows that acceleration sometimes can be negative as well. On to the fifth question, guys. This is a very interesting question. A car is moving with a constant speed of 80 km per hour, and a cycle is moving with a constant speed of 10 km per hour. In which case the acceleration is more? Would it be in option A, that is the car, option B, cycle, both car and the cycle, or acceleration is 0 in both? Very interesting question. I hope you guys are able to figure this out. I'm pretty sure that you would, but let's see how many of you guys would give me the right answer in the comment section below. However, guys, it's a very straightforward question. You could directly tell the answer, but nonetheless, I'll just show it to you guys. For the first case scenario, that is for the car, all right? The car is moving with a constant speed of 80 km per hour, which means that if you were to calculate it, again, if I were to calculate, okay, I don't know what that was all about. Arts and crafts and all. Wait a second, 1 second, people. So yes, so if you calculate the acceleration, initial minus final minus initial divided by time taken. So in this case, if you just think about it, he's moving at constant speed, which means that his initial velocity is also 80 km per hour, and his final velocity is also 80 km per hour. So if you put in the equation 80 minus 80 divided by time, so that's 0 divided by t, which means that his acceleration is literally 0. For the second case scenario, again the same thing, but this time he's moving at 10 km per hour, I believe. Yes, 10 km per hour. So again, put it 10 divided by 10 minus 10 divided by time taken, that is t, which would again give you 0 meter per second square, or kilometer per hour. Okay, if you want to convert it to meter per second, that is also possible, but at the end of the day, it's 0 itself, so you'll get the answer to be 0 in both the cases, because they're both moving at constant speed or constant motion. They both have constant motion, because that acceleration would be 0. So option number D would be the right answer for this particular question. I hope you guys were able to answer these questions, guys. With that said, moving on to your homework. Yes, people, homework. Here's the question. So this is your homework for today. I want all of you guys to do it. Try it out. Even if you don't put it on the comment section below, try out the question. There's a good practice for you people. The question is this: a truck is traveling at 54 km per hour, slows down to 36 km per hour in 10 seconds. Find the retardation in meter per second. So I'll give you some clues. I'll give you here and there some of the clues. One clue is that they're all given in kilometer per hour. So convert that to meter per second, which means that multiply by 5 by 18. So you'll get the value in meter per second. Then subtract it. Use the formula A is equal to V minus U by T. You'll get the answer. Please try out this question. It's a very, very interesting question. Try to do it by yourself and let me know what is the answer in the comment section below. Alright guys, so that is it from me. Thank you for joining. If you guys did enjoy today's session, give a like and also subscribe to the channel, because we will be coming up with a lot more content like this. So make sure to be a part of that family. With that said, if you have any doubts that you want to ask me personally, you can reach out to me on anoop.manoharan@vedantu.com. This is my personal email ID. You can reach out to me on that. Thank you for joining, people. See you all in the next one. Take care of yourself. Stay safe. This is Anoop saying adieu or bye bye, sayonara for today. Take care of yourself, guys. Stay safe and bye bye. Take care, guys.